Okay, in this video, we're going to be looking at integers and the operations of addition and subtraction. And in this section, we'll look at some of the representations of integers, integer addition, the number line model, absolute value, properties of integer addition, and integer subtraction. We'll start off with what integers are and what they represent. The set of integers is going to be denoted by the capital letter I, and it's going to be this set. And this set consists of positive numbers, negative numbers, and the number 0. That whole set consists of the set of integers. Positive numbers, negative numbers, and 0. The negative integers are opposites of the positive integers, like in this case, negative 4 is the opposite of 4. And 3 is the opposite of negative 3. Okay? So you do have the positive numbers and their opposites. And of course, the opposite of 0 is 0. And also, be mindful that 0 is neither positive nor negative. So if we want to find the opposite of each x value, like x is negative 3, we take the opposite of x, or take the opposite sign of positive 3, which will become negative 3. And then for x equal to negative 5, the opposite of negative 5 will be simply positive 5. We just take the opposite sign of negative, which is going to be positive, so it'll be positive 5. And 0 is its own opposite, which is, of course, 0. There are some ways that we can represent positive and negative integers, and we do have a few models that help us represent integers. One of them is the chip model. We can use black chips to represent positive integers and red chips to represent negative integers. Each pair of black/red chips neutralize each other. In other words, if you have a black and a red chip paired together, that gives you what we call a 0 pair. So in this case, in this illustration here, this represents negative 4 because we have four red chips and 3 black chips. That represents positive 3. So we have negative 4 plus 3. And when we combine that, a black and a red chip create a 0 pair. This black and red chip creates another 0 pair, and this black and red chip creates another 0 pair. Okay, so that means what's left is one red chip, which represents negative 1. So this is a representation of negative 4 plus 3 equaling to negative 1. Another model that we can use for integer addition is a charged field model, which is similar to the chip model. Here, positive integers are going to be represented by plus signs and negative integers by minus signs. Positive charges neutralize negative charges. Again, a plus and a minus create a 0 pair. So in this case here, we got 3 plus signs, which represent positive 3, and 3 minus signs that represents negative 5. We're adding 3 to negative 5. Well, each positive and negative sign represent a 0 pair. So we got 3 0 pairs of positive and negative signs here. What's left are 2 negative signs, or negative 2. So 3 plus negative 5 equals negative 2. And then we have the number line model, where positive integers are represented by moving forward or to the right on the number line, whereas negative integers are represented by moving backward or to the left on the number line. So if we want to represent negative 3 plus negative 5 in this case, we start at 0. Negative 3 is to the left of 0, so we go over to the left 3 to get to negative 3. And then we want to add negative 5 to that. Well, negative 5 is 5 more places to the left. So we go over 1, 2, 3, 4, 5 more places to the left. We'll end up at negative 8. So negative 3 plus negative 5 will equal negative 8. Here's an example. The temperature was negative 4 degrees Celsius in an hour. It rose 10 degrees Celsius. What is the new temperature? Okay. This is a representation of integer addition. We have negative 4 plus 10. Because it started off as negative 4 degrees Celsius and rose 10 degrees Celsius. So we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which means the temperature ended up at 6 degrees Celsius. So the new temperature is 6 degrees Celsius. And there is a pattern model for integer addition. Beginning with whole number facts, a table of computations is created by following a pattern. Now let's look at some basic facts here, like 4 plus 3 is 7, then 4 plus 2 is 6. Here the second number is decreasing by 1, or the second addend is being decreased by 1. And then 4 plus 1, that's going to be 5. 4 plus 0 will be 4. 4 plus negative 1 will be negative 3. 4 plus negative 2 is 2. 4 plus negative 3 is 1. 4 plus negative 4 is 0, and so on. As you can see, as the second addend decreases, so does the sum. It decreases by 1 as well. Next, we'll look at the absolute value of a number. So the absolute value of a number called A, and it's written like this, A, where you have the vertical bars on the outside, that represents the distance on the number line from 0 to A. Okay, so here the absolute value of 4 is going to be 4. The reason for that is 4 is 4 units to the right of 0. And the absolute value of negative 4 is positive 4. The reason for that is negative 4 is 4 places to the left. Here the distance is always going to be positive or 0. It's never going to be negative. Because definition of absolute value is the distance. So distance is always positive or 0. And this is the algebraic definition of the absolute value. Absolute value of x is going to be equal to x if x is greater than or equal to 0. In other words, if your x is positive or 0, that means you just have the absolute value of that equaling to that number itself. But if it's negative, where x is less than 0, then you'll take the opposite of x. So like with the absolute value of negative 4, if you recall, we have to take the opposite of negative 4, which is going to be 4, because negative 4 is less than 0 by this definition. And here's some examples of just that. Let's say we want to take the absolute value of 20. That's 20 places to the right of 0. That means absolute value of 20 is simply 20. The absolute value of negative 5, here, negative 5 is less than 0, so we take the opposite of negative 5, which will be positive 5. Or you can think of this, negative 5 is 5 places to the left of 0. So the absolute value of negative 5 would be 5. The absolute value of 0 is simply 0. Because it's less than or equal to 0. Here it's equal to 0, so the absolute value of 0 is 0. Now the negative, or the opposite of the absolute value of negative 3. We first take the absolute value of negative 3, which is of course 3. But the negative sign on the outside will make that 3 negative 3. So the opposite of the absolute value of negative 3 is 3. No, negative 3. And then part E, absolute value of 2 plus negative 5. First of all, we have to add 2 plus a negative 5. You can use the chip model or the charge field model if you like. You can find out that If you add 2 and negative 5 together, you're going to end up with negative 3. And the absolute value of negative 3 is 3. Okay, so we do what's inside the absolute value symbol first, and then take its absolute value. Here's some properties of integer addition. Integer addition has all the properties of whole number addition. If you recall back in chapter 3, we talked about whole numbers, and there were some properties of whole numbers that we discussed. And those properties are also applicable to integer addition. If you're given numbers a, b, and c, the closure property says that if you add a plus b together, you'll have a unique integer. The commutative property is this. Add a and b together, you'll get the same thing as adding b and a together. Okay, so the order does not change the answer. 3 plus a negative 6 is the same as saying negative 6 plus 3. The associative property of addition means that the grouping is not going to change the answer. You can group A and B together, get the sum, and add that to C. That's the same as grouping B and C together, add those two together, and then add that sum to A. Okay, so the grouping does not matter when you're dealing with the associative property. The identity element is still going to be 0 in addition. 0 plus any number is that particular number. And then you have the uniqueness, the uniqueness of the additive inverse. In this case here, for every integer a, there is a unique integer, which is the opposite of a, or the additive inverse of a, such that a plus its opposite, or its additive inverse, would give you 0. Or negative a plus the opposite of that, which is a, will also give you 0. That's what we call the additive inverse. And here's some properties of the additive inverse, by the way. By definition, the additive inverse, which is negative a, that's the solution of the equation x plus a is equal to 0. When we solve equations, pretty much to find out what x is, you're adding the additive inverse on both sides of the equation. So with x plus a, to get the x by itself, you have to add the opposite of a, which is negative a. For any integers a and b, the equation x plus a equal to b has a unique solution, b plus negative a. And then for any integers a and b, the opposite of negative a is going to be equal to positive a, and negative a plus negative b is the same as the opposite of the sum of a and b. And sometimes you can think of this backwards as a distributive property. The negative sign will change the sign of each and every term in the parentheses to the opposite. So the negative sign will make that positive a negative a, plus the negative sign will make the plus b a negative b. And here's some examples of just that. The opposite of the sum of 3 and x. And we're finding the additive inverse. Well, if we drop off this negative, you're going to end up with just simply 3 plus x. That is the additive inverse, or the opposite of negative, in parentheses, 3 plus x. Part B, a plus negative 4. Well, what you can do, if you want the additive inverse, you just take the opposite of each and every sign in this particular, each and every term in this particular expression. For a, its opposite is negative a, plus the negative 4, the opposite of that would be positive 4. So you'll end up with negative a plus 4. And the same thing here with part C, negative 3 plus negative 8, negative x. The opposite of negative 3 is 3, plus the opposite of negative x is x. So simply 3 plus x. All right, now we already talked about addition. Now we look at subtraction of integers. We also can use a chip model for subtraction. In this case, if we want to find 3 minus negative 2, you want to add 0 in the form of 2 plus negative 2. In other words, 2 black chips and 2 red chips. So we're going to need 2 0 pairs here to the 3 black chips, and then you can take away your 2 red chips. So here, for 3 minus negative 2, we start off with 3 black chips. But we want to take away 2 red chips. Unfortunately, we don't have 2 red chips in here. But we can place them in here by using 0 pairs. So here, I have 2 0 pairs of red and black chips. In this case, 2 black chips and 2 red chips. Now I can take away these 2 red chips out of this circle. And when I do that, I'm left with 5 black chips. So that gives me the answer of 3 minus a negative 2, which is 5. So this is the physical representation of using a chip model to subtract integers. Another model similar to the chip model is the charge field model. If you want to do negative 3 minus a negative 5, here you want to represent the negative 3 with 3 negative signs, but we want to take away negative 5 negative charges, which means you need 2 0 pairs. You can put 2 of these negative signs in here, but if you're going to put 2 negative signs in there to compensate for that, you must put 2 plus signs in that circle as well. Now we can take away negative 5 charges. We're left with 2 positive charges. So this is an illustration of negative 3 minus negative 5 equal to 2. And then the number line model can also be used to represent integer subtraction. While integer addition is modeled by maintaining the same direction and moving forward or backward, depending upon whether a positive or negative integer is added, subtraction is modeled by turning around. Okay. And here's the pattern model for subtraction. Using inductive reasoning and starting with known subtraction facts, the difference of 2 integers follow a pattern. So in this case here, you see 3 minus 2, that's going to be 1. The subtrahend, the one we're subtracting from, is going to be increasing. Or actually, it should be decreasing, by the way. But you'll see a pattern here. 3 minus 2, that's going to be 1. 3 minus 3 is 0. 3 minus 4 is negative 1. 3 minus 5, that's equal to negative 2. Then we can say 3 minus 2 is 1. 3 minus 1 is 2. 3 minus 0 is 3. 3 minus negative 1 is 4. On the left side, the subtrahend is increasing while the difference is decreasing. And on this side, the subtrahend is decreasing while the difference is increasing by 1. We can subtract using the missing addend approach. Subtraction of integers, like subtraction of whole numbers, can be defined in terms of addition. Like in this case, we can compute 3 minus 7 as follows. 3 minus 7 will give us some number n if and only if 3 is equal to 7 plus n. In other words, 7 plus some number must give us 3. And that only number that could do that would be negative 4. Because 7 plus negative 4 is equal to 3, we can say that n is equal to negative 4. So 3 minus 7 is equal to negative 4. And this is the definition for subtraction of integers. For integers a and b, a minus b is a unique integer n such that a is equal to b plus n. And we use that definition to compute these type of problems like 3 minus 10. So 3 minus 10 is going to be equal to some number n, which means 10 plus some number must give us 3. Okay? A big number plus some number is going to give us a smaller number, which means that n had to be negative. So in this case, n is going to be negative 7, because 10 plus negative 7 gives us 3. So n is negative 7. Then part B, 2 minus 10, negative 2 minus 10. We'll let n be negative 2 minus 10, meaning some number plus 10 gives us negative 2, which means it'll have to be negative 12, because 10 plus negative 12 does give us negative 2. Okay, we can use the approach of adding the opposite, which is the approach that most algebra textbooks teach, most mathematics textbooks teach when you're dealing with integer subtraction. Subtracting an integer is the same as adding its opposite. In other words, if we have all integers a and b, a minus b, it's the same as a plus the opposite of b, which is negative b. So we change subtraction to addition and then take the opposite of the second number, because subtracting an integer is the same as adding the opposite. Like in these examples here. In part A, you got 2 minus 8. 2 minus 8, that's the same as saying 2 plus negative 8. With subtracting positive 8, that's the same as adding 2 to negative 8, which would give us negative 6. 2 minus a negative 8, with subtracting a negative 8, that's the same as adding a positive 8. So you just simply have 2 plus 8, which is 10. Negative 12 minus negative 5, with subtracting negative 5 from negative 12, that's the same as adding negative 12 to positive 5. You'll end up with negative 7. And then finally, negative 12 minus 5, with subtracting positive 5, that's the same as adding negative 5 to the negative 12, which will give you negative 17. And also, you can use those rules for addition that are taught in textbooks. If you have the same sign and you're adding, you keep the common sign and add the two numbers together. Like in this case right here, adding negative 12 to negative 5. You bring over the negative and then add 12 plus 5, which is 17. But with different signs, you have to subtract. If you're adding two numbers with different signs, you subtract and take the sign of the larger number. Like here, negative 12 plus 5. 12 is a larger absolute value. It's negative, so the answer will be negative. Subtract 12 minus 5, you'll get 7. And here you want to write expressions equal to each of the following without parentheses. Like in this case, they're the opposite of b minus c. The negative sign is on the outside. Now you could do this. That negative will make the positive b negative b. The minus sign will make the minus c plus c. So your final answer would be negative b plus c. And then a minus, and in parentheses b plus c. In this case here, this minus sign will make the positive b negative b, and then the minus sign will make the plus c a minus c. Negative c. Here they wrote this as a plus negative b plus negative c. Another way you could write this as a minus b minus c. That's another way you can write this. Then simplify each of the following here. 2 minus, and in parentheses 5 minus x. Now the way that you can do this I'm going to do it differently from what they have here. Bring over the 2. That minus sign will make the 5 a minus 5. Then the minus sign will make the minus x plus x. So now you get 2 minus 5 plus x. Well, 2 minus 5 is the same as 2 plus negative 5 plus x. Then if you add negative 2 plus 5, that's going to give us negative 3. Bring over the plus x. Or we can say that negative 3 plus x is the same as x minus 3. And then part B, 5 minus, and then parentheses x minus 3. Bring over the 5. The minus sign will make the x minus x. The minus sign will make the minus 3 plus 3. In this case here, 5 plus 3, we combine the like terms as 8 minus x, which is exactly what they have here. So here, you'll end up with 8 minus x. And if we want to simplify this one, the opposite of x minus y, minus y. Here, this negative sign will make the x minus x. The negative sign will make the minus y plus y, and then bring over minus y. Okay, now we combine like terms. Y minus y, that's gone. You're just left with simply negative x. Okay. All right, next is order of operations. Recall that subtraction is neither commutative nor associative. It's not commutative. An expression of such as 3 minus 5 minus 8 is ambiguous unless we know in which order to perform the subtractions. Mathematicians agree that 3 minus 15 minus 8 means this. 3 minus 15 first, and then minus 8. So subtractions are performed in the order from left to right. So in this case here, 2 minus 5 minus 5. We first do the 2 minus 5, which will give you negative 3. Then negative 3 minus 5 will give you negative 8. So here we're doing this subtractions in order from left to right. Part B, we have a subtraction and an addition, but we do the subtraction first. 3 minus 7, we do that first. That's negative 4. Negative 4 plus the 3 will give you negative 1. In this case, part C, you have parentheses here. So we first do the parentheses first. 7 minus 3 will be 4. So now you'll have 3 minus 4 to work with. So 3 minus 4 will give you negative 1. Okay? And that will conclude this particular video on the integers and operations of addition and subtraction.